Hi, Peter. How you doing?
Hi, Ms. Kane.
All right. I think we're good. These readers really loud.
Mrs. Kane.
So today we are going to go over a handful of questions from the book. It seemed like the two problems that were closer to the end of the assignment with the two graphs. Those seemed to be good questions to talk about. They were giving you two graphs and you were trying to find the combinations of functions using the two graphs. I'm going to go over one of the last problems as well because we didn't quite get to the problems where you have the two functions or the combination function, the composite function, and you want to kind of break it apart and find the two functions that make it. So we're going to go over those. Really, we have like one more problem to look at today. And it's actually a difference quotient problem because a difference quotient problem is kind of like a combination of functions where you take two and you're subtracting them. So that was a concept that we talked about in the first part of the chapter. And we're going to continue working with that. And that will like kind of spiral back in various times throughout the year. Your tests are graded. I don't think I put them in Power School yet. And I don't think I returned them to you yet. Did you get a test back? No, okay. I will return them to you today. Posted on Google Classroom sometime today will be a form that if you want to do test corrections, you can. I sometimes have opportunities to retake a test. Not every test you'll have the option to retake. So I will let you know generally if there is an opportunity for you to retake a test. You're not going to retake this test because the turnaround is too quick by the end of the chapter 1 test, like the end of chapter 1. It's actually next Friday. So chapter 1 test is next Friday. So for you to retake a test, it's too quick of a turnaround because I need the test to be retaken before you take the next test. But instead, I'm going to give you the opportunity to make test corrections. And those test corrections, I think I can pull it up. Yeah, I feel like I have it here. For those of you at home, I'm going to share the test correction form just so that you can see what it looks like. So
Mrs. Kane.
for my test corrections,
Mrs. Kane.
pretty much if you miss, who is? No, and I can't hear anything coming out of my MacBook.
Go ahead.
You're
Go
cutting
ahead.
out really bad.
They said you're cutting out
Okay.
really bad.
Do you mind bringing yours up?
Is it better?
Yeah, that's better.
Yeah, that's better now.
All right, thanks. All right, so I'm gonna start over. So test corrections. If you miss 1 point or more on a problem, you're gonna write the original problem down, the number or like the section it came from. You're gonna correct it, and next we're gonna find a similar example. And then underneath, the next thing I have here is for you to kind of just explain why the problem was solved incorrectly, what you were thinking about when you solved the problem. You will receive half credit back for any problem that you choose to do a test correction for. Again, you're not actually redoing the test, you're not retaking a test. This is just to earn some extra points back on the test. Sorry. So this will, usually I use this form and you retake the test, but there's just not enough time to do both with the turnaround of the chapter 1 test being so soon. But I want you to at least have the opportunity to look, review the material, correct the material that you got wrong because it's still a great learning experience. So you would do this for any test that you would make or that you would want to retest on. Just we're not doing that the full process this time around. Does that make sense? Okay. Something similar, yeah. I don't do the interview process that she does. My process is like more of you're writing the explanation as to what you did instead of like actually meeting with me. And that's because we're dealing with a different level of students. So when I'm dealing with sophomores and juniors and not freshmen and sophomores, it's a more advanced class. Mrs. Everhart uses a similar system as well. And she's the AP class teacher. So I'm going to post this on Google Classroom today. I will say the tests weren't horrible, but there were a lot of C's. I'd say the class average was probably around an 81 or an 82%, which is kind of low. I know it's hard learning remotely, so that's probably part of it. It's also hard because March, April, May, I mean, yes, you were still learning, and I know if I had you as a student, we were still continuing to go through stuff, but you weren't meeting with a teacher every single period, every day of the week. It was totally different in the spring. So there is going to be a learning curve to get back into the idea of what you need to do to prepare for a test and just the level of the class that we're talking about and what it takes to prepare for an honors training for top test versus an honors algebra 2 test. And it's going to take more. You're going to see that. So if you'd like to earn some points back for your test, again, this form will be posted to Google Classroom. It isn't there yet because I wanted to talk about it first. But it'll be posted to Google Classroom. Once you get your test back, sent back to you, write the problem, find one similar to it. So look in your book at the problems we did in your homework, look at your notes, but you need to find one similar to it so that I can see that you're practicing another example similar to the one that you used. If you have questions on any of that, email me, talk to me after class. If you're at home, send me an email if you're not sure about the test correction process.
Mrs. Kane.
That's cool.
I have to go at 9:15. I have a hockey tournament and we have to drive down to Cleveland, so.
Yeah, that's fine. Just leave the Zoom whenever you need to. It'll be recorded, but we have about 1 or 2 examples to go over, so you might get to see most of it.
Okay, thank you.
Thanks for letting me know, Cole.
Yep.
All right, so we are going to look at the homework for last night. And as I said, I picked a couple of problems that I saw students asking questions about, which is what I typically try to do. And I thought we would look at the graphing problems first. So these 2 graphs are given, and we could write an equation for the graphs because one looks like absolute value, the other one is a line. But we also can evaluate functions just by using the graph. And that's the goal. Like, can you do it both ways? Can you use a function and an equation, but can you also look up values in a graph? So looking at number 67, I'm going to place it on the side here. 67 wants us to find f plus g of 3. What does that really mean we're finding? F plus g of 3. What's another way we could write that? Jeremy, how else could I write f plus g of 3? So how else could I write this notation? What does it mean, f plus g of 3? Yeah, that really means we're finding f3 plus g3. So two different ways to write the notation. This is keeping the two functions together. This is separating it and saying we're really finding f of 3 and then g of 3. This number in the side here in the parentheses, what's that represent? What's the 3 mean? Darby. Yeah, that's what we're plugging in for x. If I had an equation, I would plug that number into the equation. I have a graph. So that's the number I'm looking up in the graph for x. So here's my graph of f of x. It's on the right side or the left side here. Here is 3. I'm going to look up that value. F of 3 is equal to whatever my corresponding coordinate is. Well, if x is 3, y is 2. If I would plug that into the equation, I would get out the value of 2 as well. Anytime you plug in x, you get out y. Anytime I look up x, I'm finding y. So then g of 3, again, go to where it's 3 on the graph, find its corresponding value. Well, that's a 1. If I plugged it into the equation, I would get a 1. By looking up that x value in the graph, I'm looking at its y value, I also get a 1. And when I add them together, I get 3. So f plus g of 3 happens to also equal 3. So that's evaluating using a graph instead of evaluating using the actual equation. So a graphical approach. So if I look at part B, not number, so that was part A. So if we take part B, so this is really saying take f of 2 and divide it by g of 2. So Brenna, if I look up f of 2 in the graph, what is f of 2? 0. All right, just to look it up, Brenna, g of 2 is, and 0 divided by 2 is, that's 0. So this is part B. So looking at the graph, finding the x value in the graph, getting its matching y value. You're actually going to have a few homework problems tonight that are more application-based. And 2 of those homework problems will use, if it's not the same graph, it's very similar set of graphs. Questions on that? So evaluating a function, a graphical approach instead of the equation approach. The other one that I wanted to look at, I think, was 73. Pretty sure it's 73. Yes. So 73 says, identifying a composite function. In the exercises, we want to find 2 functions, f and g. So essentially, I want to know what f of x is, because I don't know what it is, and I want to know what g of x is. So that's what we're finding. We're finding the 2 functions. Such that, and here's where it gets a little weird, f of g of x is equal to h of x. So what this is saying is this h of x function is really my f of g of x function. So yesterday we talked about making composite functions by taking 2 functions, substituting one into the other. Well, this problem is asking you to do the opposite. So the functions have been combined together. This is the composite function. We want to pull them apart and find the 2 separate functions that would have created this. So essentially, you put the puzzle together, your bratty little brother came by and totally destroyed your puzzle. I had a bratty little brother and a friend, and they took probably 5 boxes of puzzles and just dumped them all together. And then I had to take them all apart, my mother and I, and separate them back into the original boxes. I think my brother was 5. I still remember that. I was probably like so mad at him. He's now 38. Still mad at him for that though. I don't hold any grudges, not at all. So think about this. You've got the puzzle put together. We want to pull them apart. If I look at this problem here, what does it look like g of x represents? And it does say you could have multiple correct answers. But if g of x is what we plug into the equation, what does it look like would have been substituted into this answer? That's my g of x function. Does anybody have an idea? Grant? Yeah, because that's kind of like in parentheses underneath the radical. That's what you would have plugged in. So that's g of x. So the inside function is my g of x. So Grant, if we take that out, what function are you left with? Yeah, just the cube root. And what's probably going to be under that cube root? Just an x. So if those are my two original functions and I did the composite function, I would take the g of x and replace it for x. That's how I get to this equation. So it's kind of like separating it apart. Does anyone have questions on that? Are there any other questions that I didn't answer? Yeah. Yes, you could definitely replace that in. As long as whenever you substitute it in for x, you end up getting that same answer. Yep. So as long as you plug it in and you end up getting that same answer. So there are multiple ways that you could do it. I think this is probably the most like visual one to just piece them apart. You thought more about it than you probably needed to. That's okay. Other questions? All right, so make sure you're submitting your homework, especially with corrections. Feel free to resubmit the assignment. If you made corrections to it, just resubmit it. You can just submit the extra attachment of the corrections that you made for your assignment. So we are going to look at, I think, 2 examples in your notes. So if you'll take out your notes, we have example 8, and then we are going to look at example 9. Example 8 kind of wraps up the composite functions. Example 9 is a review of that difference portion. So I don't even know what page this is. Doesn't have a page. Should be at the bottom, but it's, I mean, you're all on notability, so it's just 30. Yep. All right, so we have 2 functions, the square root of x, and then we have another function for g of x, it's x minus 1. And then it gives us this little piece here. It says only when x is greater than or equal to 1. And it wants us to find f of g of x and its domain. Well, they already gave me the domain of g. So maybe we might need to use that eventually when we try and find this information. See if you can find f of g of x first. So f of g of x. After you get that, try and find the domain. What is the domain of f of g of x? So you're plugging in the equation, the g equation. That replaces x in the other function. So my other function was a square root. X becomes x minus 1. So what would the domain of this function be? Pardon? So 0 with a bracket? Okay. So let's look at that. What happens if you plug in a 0, Darby? Yeah. So 1 with a bracket up to infinity. It does have to be greater than or equal to 0. Remember, anytime you have a square root, it has to be greater than or equal to 0. But that means my x value really has to go from 1 up to infinity. So that domain goes from 1 to infinity. All All right, so the next one says find f of g of 2. Okay, don't think too hard here. We just found f of g of x. So we found f of g of x. What do you do with the 2? Grant, what do you do with the 2? Plug it in for x. So if I plug it in for x, Grant, I get, yeah, what is the square root of 1? 1. So f of g of 2, take the f of g of x equation, plug in 2. All right, let's look at letter C here. It says f of g of 0. What does this 0 represent? What's the 0 mean? Jenny? What you're plugging in for x. What's wrong with plugging 0 in for x, Jenny? It will make it negative. What's the domain of our function? 1 to infinity. The reason we think about domain is because that gives us restrictions on x. If they give me an x, or I give you an x, that doesn't fit in the domain, then you can't solve the problem. I mean, you could try, but Jenny said you get a square root of -1, which doesn't work. So this one is undefined. Because 0 is not in the domain. That's why we think about the domain and the restrictions, because you could get a number that doesn't work. Well, why doesn't it work? Because it's not supposed to. It's not in the domain. So I don't even need to solve it. I mean, you could, but it still can't work when you solve it. So just make sure you're looking at x. Does x fit in the domain? That's why with those difference quotients, we said h can't be 0, because again, that doesn't fit in our domain, the graph or the function. So we have one more problem that we're going to do. And that's this difference quotient. And I wanted to go over it again. I saw a lot of misconceptions with this problem on the test. It's really good to keep working on these because it is kind of a difficult concept to understand. So we have the difference quotient and the function 1 minus x squared. The most important part to remember is that you apply things to the function. You replace x in the function, not the other way around. So this says f of x plus h. That has to go in place of x in my function. So my function says 1 minus, so I have 1 minus. And then it says x squared. That was my original function. But I'm replacing that with x plus h. That's what f of x plus h means. Go to your f function, replace x. So there's x plus h. So it still says 1 minus x squared, but now it says 1 minus the quantity x plus h squared. The second part says subtract, so I'm going to make a big subtraction sign. And it says subtract f of x. Well, f of x is 1 minus x squared. That's what f of x represents. That's its equation. Make sure you subtract all of it. I put it in parentheses to remind myself I have to always subtract the whole thing. And then I have it divided by h. So again, I'm using the equation. And I think that's the biggest mistake that I'm seeing is students aren't using the equation and replacing x in the equation. Instead, you're trying to like add an extra h somewhere in the problem to show that you have an h, but we're replacing the equation. So I still have 1 minus x squared. I'm subtracting f of x. And now I have to do some simplifying. When you simplify and you FOIL x plus h times x plus h, there are two xh terms because I'm taking x times h times x. There are two of them. And then h squared. Every time you FOIL x plus h squared, it always makes x squared plus 2xh plus h squared. I kept it in parentheses though because there was a minus sign in front of it. And yesterday we had a problem with the minus sign. And we said that minus sign went to everything inside. The next part, I have a -1 and that becomes a positive x squared. So really this becomes 1 minus x squared happens then? And then the two terms we have left, what do they have in common? An H. If you also wanted to take out the negative sign, you could, because they also have a negative sign in common, they're both negative. And I'm left with 2x plus h if I pull that negative sign out. Once I pull that out, that's when the denominator cancels, because I pulled out the h. They all had an h in common, so that enables our denominator to cancel. And again, that's like the piece that happens with all of these different quotients. So my final answer is just 2x plus h. And then I factored out that negative to keep it a positive quantity. The last part of your answer, again, is that domain, the restriction. What can't x be? Well, it started out, or h, sorry, not x. H started in the denominator. Even though we got it to cancel, I could evaluate to start the problem instead of evaluating to end the problem. You can evaluate two different places. You could evaluate with the original expression, or you can evaluate with the answer, the simplified expression. So that's why we have to say that h can't be 0. Questions? So this is something that, like for some of you, when you get your test back, this is an example of the difference quotient. Maybe star this, look over it. If you continue to have problems with these, look back at the video again. But try and like follow the pattern of setting these problems up. I know the one on the test was similar to this. So those are all the notes that we're taking today. If you look continuing down, I don't think I have it on my screen. If you scroll down into your notes, there are 2 application worksheets. Thank you. So Ms. Karp said pages 33 and 34. They should just be the next 2 pages in your packet. Worksheet number 1 has 2 word problems on them. And I can see that this is dealing with composite functions. Here we go. So this is what worksheet number 1 looks like. It is open for you in Google Classroom if you want to use the assignment in Google Classroom, or it's in your packet. So like if you just keep scrolling in your packet, it's already in the packet as well. I just made it a separate assignment in Google Classroom. And then there's another worksheet right after that in the packet. And that second worksheet. No, maybe I have them both on here. Yep. So that second worksheet should just be right underneath. And here you can see those 2 equations from the book, the 2 graphs from the book. And you answering the questions based off of the graph. And then there's another word problem. So you have a couple of word problems, 3 word problems, and really 4 graphing problems, analyzing a graph. That's the homework for tonight. You have about 10 minutes. The class goes till 9:33. So there's 10 minutes to get started. If you're at home, you can feel free to stay on or you can leave. Those of you that are in the class, you can ask each other questions. You can ask me questions. I'm going to walk around. You can shout over to Darby, Darby, what did you give for number 1? So have a great day for those of you that are at home. Again, I'm going to be here. So if you have questions, please let me know. Yeah, just